Okay. This is the third time I've tried to record this video, so let's hope I do it right this time. So, first of all, it says 3 things to always keep in mind. We've talked about taking the integral of velocity before, and think about if we take the integral of velocity, the antiderivative is going to get us back position. And so, if we take the integral from a to b of velocity, we're actually going to get the net distance of a particle traveling from a to b. If velocity never changes directions, it's actually also going to be the total distance. Now, if we take the absolute value of the velocity function, remember that that's going to give us the total distance where you have to break it up at the parts where it changes direction. So it says, doing this without a calculator, given the velocity 3t squared plus 6, and if the particle is at t equals 472, what is the position when time equals 2? So if we put it in the order that we know it should go in, right? What is the position when the particle equals 2? I always thought it matters which one you do, but it doesn't seem like you do. So let's see if I can screw this up again. So if I say from 2 to 4 of 3t squared plus 6, then that would equal p of 4 minus p of 2. And so 3t squared would be 3t cubed over 3, or just t cubed plus 6t from 2 to 4. And then we know p of 4 is 72 minus p of 2. So t to the third is 64 plus 24 minus 2 to the third is 8 minus 12. And so I would get, what, 88 minus 20, which is 68. And then if I subtract 72 over, that's going to be negative 4 equals negative p of 2, or p of 2 equals 4. I've always wanted to rearrange the points at first, and by rearranging them, it messes with this side, and it still works that way too. But it really works that I could just start with t of 2, and it just makes this be in the opposite order as well. And so it says, what is the total distance that the particle travels from 0 to 7? Well, how do we know if it's going to be positive if it's no calculator? Well, think about this. In this function, will the velocity ever equal 0? No, because it's 3t squared plus 6, so no matter what we plug in for time, it's going to give us a positive number. So since it's never changing directions, we can just do the integral from 0 to 7 of the velocity function, and that's going to give us the total distance. And so I know that it's t cubed plus 6t as my antiderivative from 0 to 7. And so that's going to be 7 to the third plus 6 times 7 minus 0. So I'm not going to say 0 to the third plus 6 times 0 because I know that it's all 0. And if this was really without a calculator, I would just leave my answer like that instead of working out 7 to the third. But I used my calculator and got 385 because it didn't change directions. So this one says the velocity of a particle that's moving along the x-axis is given by this function. This is a calculator active question. And it says if the position of the particle at 1.5 is 2.551, what is the position at time equals 3.5? So again, even if you're using your calculator, set up the integral, right? So I can do from 1.5 to 3.5 of the velocity function. And I know that's going to be equal to v of 3.5 minus v of 1.5. Show that on a free response question. And then remember, Math 9 on your calculator, you can type this in. You can type this in your calculator, and your bounds in there, and it's going to give you the answer. So please practice doing that, and you should get 15.919. Oh, why did I say v? That should say p, shouldn't it? And then I'm looking for P of 3.5. And how am I going to get P of 1.5? Oh, because they told me, right? 2.551. Sorry, I was struggling. And then I'm just going to add that over. So I get P of 3.5 equals 18.470. What is the total distance? Again, you can look at this or set it equal to 0. You have a calculator. But if you look at it, it isn't positive the whole time. But what's fantastic is when they ask you for total distance on a calculator problem, you can plug in the absolute value on your calculator. So it really should be like close the absolute value bars and then D of t. So if you hit catalog 1, it gives you the absolute value bars. So you should try to find that and see if you can do it. And it gives you the absolute value bars. So if you hit second 0, that gives you catalog. And it's ABS for absolute value. I think it's also under the math button. But it's all on your calculator. And this is on the free response sometimes as a question. Show this, type it in your calculator. You get your answer. Fantastic. And the last thing here, it says the graph of the velocity measured in feet per second of a particle moving along the x-axis is pictured below. The position of the particle at time equals 8 is 12. Use the graph to answer the questions that follow. What is the position of the particle at time equals 3? So I'm going to do the integral from 3 to 8 of the velocity function. And I know that's going to equal the position at 8 minus the position at 3. But now I don't have an equation. Now I have a graph. So from 3 to 8, I need to do the area. And again, I'm not scared of trapezoid, so I'm going to do this as a trapezoid. So that's going to be 1/2. And the height of that trapezoid is the distance right here. So from 0 to 5, so that's a height of 5. And the base is 1 plus 3. Plus this one, but it's below the x-axis, so be careful of that triangle. 1/2, the base is 2, and the height is -2. And I'm going to set that equal to P of 8, which is 12, minus P of 3. So 4 divided by 2 is 2, times 5 is 10. And that cancels out. So 10 minus 2 is 8. And subtract the 12 over. So 8 minus 12 is -4 equals negative P of 3. So P of 3 equals 4. Part B says, what is the acceleration at time equals 5? Well, if this is the velocity function, at 5, the acceleration is going to be like the derivative, right? The acceleration at 5 is the same as the derivative. And derivative is just slope. So at 5, can you think about what the slope is? I'm going down 5 over 2. So -5/2. And they do tell us that this is in feet per second. So we could even say feet per second squared. Part C says, what is the net distance the particle travels from 0 to 10? So net distance means canceling out the negatives, right? And so the net distance is going to be the integral from 0 to 10 of the velocity function. And then I'm going to do just this big trapezoid, which is going to be 1/2 times the height, which is 5, and the bases are 6 plus 2 plus this triangle 1, 2, 3, 4, 1/2 times 4 times the height of -2. So 8 divided by 2 is 4. 4 times 5 is 20 minus 4. The net distance traveled would be 16 feet because it traveled 20 in a positive direction and then -4 in, or 4 in the negative direction. And then part D says, what is the total distance? So total distance is represented from 0 to 10 by the absolute value of velocity. And it's still the same, it's still 20, but now I'm taking like the absolute value of 20 plus the absolute value of -4 to get that the total distance is 24 feet. So because it changes directions at 6 seconds, that's why those aren't the same. Okay? So I have a video that was already pre-made for the rest of these notes. And so since I'm not here, you're going to watch both, 2 videos in one.